In this course, I will show you how to work with particles in Houdini. We will cover a lot of different topics from pop solver to pop forces, volume advection, instancing techniques, and much more. Let's start. To do a particle system in Houdini, you should create geometry, go inside, hit up, and type pop network. It will create for you DOP network with basic nodes needed for particle simulation. If you will hit play button now, you will see that nothing happening simply because we didn't set up any emitter for particle system. To fix that, we should set up emitter itself. As you see now, emission type we have scatter onto surface, so we need a geometry as an input, and geometry source is the first input of pop network. So let's go up to SOP level and create a sphere. After that, connect it to first input of PopNet. I will move sphere up. And now if we hit play, we can see that particles start scattering onto surface of the sphere. We have a checkbox for guide geometry. You just create a ghosting wireframe so you can see where's your emitter. Let's create a gravity force node. As you see, it's pointing downward with 9.8 value. And if we start playing now, the particles start moving down. Next emission type, if we click on drop-down menu, would be all points. Basically, sourcing will happen from every point of our input geometry on every substep of simulation. And as you see, if we start playing simulation, it's constantly emitting from every point on every substep. Next emission type is all geometry. So basically it's taking geometry and on every substep we'll start inject it into particle simulation. Emission type points is basically taking and randomly scattering points onto points of input geometry. I will choose scatter onto surface, and now we can check the different geometry source options. Besides choosing the input of pop network, you can set parameter instead, set a path to a node. In that case, you should choose from drop-down menu in geometry source parameter, use parameter values, and simply copy path of emitter node and paste it into SOP parameter. With emission type scatter onto surface, we have a source group parameter. It gives an option to choose polygons where emissions should happen. Let's go up to SOP level and select a couple of polygons. After that, press Tab in viewport and create group from selected area. Let's change group name to emitter, go inside pop network and choose emitter group. And now particles emitting only from the polygons which inside emitter group. I will remove the group, and now we can check parameter called emission attribute. Here we can select point attribute, what will control emission amount of particles. Let's jump to SOP level. I will change primitive type to polygon for the sphere and increase frequency to have more points. Disable group node and create attribute VOP. Dive inside, create turbulent noise, plug position, and output of the noise I will plug to color so we can easily see the appearance of the noise. When it's ready, I'll create bind export to export attribute, name it emit. And now we can go back to pop network and choose emit attribute in emission attribute parameter. I'll disable gravity for now, so you can easily see the places where it's emitting from. And as you see, now this attribute is working for the probability of emission. Alright, let's remove it. And before we go to burst tab, let's check parameter called remove overlapping. To show how it's working, I will switch emission type to all points, hit play and display point numbers. So now you can see that every time step, points created in same position, and it's leading to issue that we have overlapping particles. Basically, this parameter helps us to remove such points and make simulation lighter. Just choose from drop-down menu with existing. And that's it. Now time to go to Burst tab. This tab responsible for emission amount, source and activation, and particle lifespan. If we have emission type all points, we have only one option for activation is to be active or not active. Value of 1 equal to active and value 0 will deactivate the emitter. And in that case, we can put expression or animate by hand the keyframes. Let's enable gravity back. For example, let's set expression $f equal to 10, what means that in frame 10, source will emit particles. Now we can check different emission type. Let's remove expression and set activation to 1. Change emission type to scatter onto surface. This type have constant and impulse activation options. I will set constant burst rate to 5000, what means that source will emit 5000 particles per second. You can animate constant emission as well. For example, we can set expression $f less than 10, which means activation will happen before frame 10. Maximum scene points, it's a limit for particles for this network. So if particles amount exceed this number, new particles will be not created. Maximum points per frame, it's a limit for the amount of particles emitted per one frame. Just born group. Here you can put a name for the group, what will include just born particles for same substep, and then they will be removed from that group. Let's put a name for the group just born. Go up and create a split node to isolate just born group from mainstream. And now you can see that this group contain only just born particles on their first frame. Seed parameter give random value for particle distribution. Life expectancy, it's a lifespan of particles in seconds. So if I set 1, it means the particle will live for 1 second or 24 frames. It depends on your animation settings, but by default, Houdini set FPS to 24. As well, you can use life variance to add variety to lifespan of particles. Amount here as well set in seconds, so this amount will be subtracted or added to life expectancy value. Now we can go to Attributes tab. Here you can choose what attributes particles should inherit from the emitter and set initial velocity. By default, initial velocity set to use inherit velocity, what means when particle born, it will look into source geometry for velocity attribute, but we don't have it. So let's create it. Let's go back to SOP level and create point velocity node. I will click on Add Velocity checkbox and set 3 in y-axis. Let's display point trails, and it shows that now we have velocity attribute. Go back to Pop Network, and if you start play now simulation, you will see that particles start moving up. And now with parameter inherit velocity, we can control scale of inherited velocity. As well, we can add to inherited velocity, so it will use velocities from source geometry plus additional values what we can set here. Let's disable point velocity node, and now we can check last option, set initial velocity, where you can set vector for initial velocity of the particles. Checkbox add ID attributes is very important. It's turned on by default and it should stay like that, because particles basically it's a points. Points have point numbers, but because particles dying over time, it means that point number for them will be changed, and ID attribute give consistent unique number to every particle, so later we can easily manipulate on them. Stream tab. Here you can find name of the group where particles from that source will be added to. By default, here's expression $OS, so basically it's reading the name of the node and using it as a name of the group after stream underscore. It will be very helpful if you have couple of sources and later you can split them. Let's duplicate pop source node, go to SOP level, duplicate sphere and move it to side. side and connect it to second input of POP network. Now in the source tab of second POP source node, we should choose use second context geometry, and now we have two sources, and since the name of source nodes is different, it will add particles from different sources to different groups. Now we can go up and in split node choose one of stream groups. That's how we can easily access later particles from different sources. Let's remove second source, and now time to speak about POP solver. I will set initial velocity to 0 and set constant activation to 1. Unmute gravity and increase its value a lot until I start to see a substep issue in the viewport. Alright, as you see, we have these gaps between particles. It's coming because of substep issue, because particle travel too fast. To solve that, we can go up and in simulation tab of DOP network, we can increase global substep value. Now as you see, the particle stream gets rid of these gaps between particles. The issue with this method would be that you force DOP network constantly do same amount of extra substeps. So let's speak how we can do it adaptively to optimize calculations. Go inside and select POP solver. In here you will see minimum and maximum substeps parameters. And CFL condition is basically a threshold which helps to understand solver what amount of substeps it should apply. It takes into account particle travel distance. Let's set maximum substeps to 11. And as you see now, nothing happened. It's because to make it work, we should have a p-scale attribute on particles. P-scale is a common points or particle attribute in Houdini, which determine a size of the point or particle. Let's create p-scale attribute. Go up and create attribute create node. Set name to p-scale and value to 1. Let's split top bottom viewport and open geometry spreadsheet window where we can browse all attributes information. And now as we see, we have p-scale attribute and its value equal to 1. Go back to simulation. And if we click play now, we will see that step start working. If you want, you can decrease CFL condition to make solver be more sensitive to travel distance. Update tab allows us to choose basic option of solver. Basically, you should just keep it as it is. In collision behavior tab as well, we should do nothing. We will speak about collisions later. But here you can set defaults for response on collision, should particle die or stick or slide, and disable collisions if you need as well, and choose which attributes you want to be added to particles on collision. Let's talk about sleeping tab. You can turn on auto sleep. It means that particles with low velocities below the velocity threshold will be put to sleep. It's controlling by stopped attribute, and I'll show you now how you can work with this stopped attribute to control activation of particles. Let's go up to SOP level and create a box. Change size, create points from volume node to scatter points inside of box. Connect it to first input of POP network. In POP source, choose all points and set expression $f equal 1 to emit particles only in first frame. Disable gravity and adjust life expectancy to higher value. If I enable auto sleep and go to geometry spreadsheet to check attributes, we will see that now we have stopped attribute applied. Now it's equal to 1, what means that particle is deactivated now. And if I enable gravity back, you see that it's not affecting these particles. Let's try to activate some of them. We can do it in different ways. For now, I will show you how to do it with group. Let's create pop group node. We will talk about this node in details later. Choose name for group. I will write activate. Go to bounding tab and click enable. Switch bounding type to sphere. Adjust size and position. Now you can animate sphere in a way it going through the particles. To set animation keyframe, you should hold Alt and click on parameter. Then go to frame 74, adjust new position, and set keyframe again. Now we have bounding sphere, which go through the particles, and all particles which inside this bounding sphere will go to group activate. Now we should create new node called pop Wrangle. It allows us to use Vex expression to manipulate attributes. Again, we will talk later about it in details. Now I just want to show you how working attribute stopped, connected after pop group, and put expression if group activate equal to 1, then attribute stopped equal to 0, which means the particle will become active again. Play animation and you will see that particles inside of group activate start be active and gravity can influence them. Alright, that's how stopped attribute working. Now let's start from scratch. Let's remove all nodes, create a grid, and pop network. Go inside, create gravity. Before we start to speak about pop nodes, I forgot to mention one important parameter in pop solver called timescale. Basically, it's simulation speed, and it will set is particles interacting fast or slow. This parameter also can be animated. Let's set couple keyframes to prove it. It can be very helpful when you like overall forces and motion in your particle system, but just want to make it slower or faster. Delete animation. First node I want to talk about will be pop color. Press tab and create pop color node. This node will create CD attribute for particles, which mean color diffuse. And first color type, what you can see, it's a constant. So basically you're applying to every particle same color. You can choose any color you want in color editor. Next color type is random. It assigns random color based on particle ID to every particle. So as you see, we have a little Vex expression and you have a seed parameter. So basically you can change random distribution if you don't like original one. Next color type is ramp. As you see in Vex expression, it uses normalized age. So basically it takes age attribute and divide it by life of the particle. In this case, values will be between 0 and 1, so it can easily fit the ramp and you'll have a better control over it. By default, particle life is really huge number, it's 100 seconds. Let's set it to 1 so we can easily check how ramp is working. And now you can see when particle is born, we have one color and it's black, and in the end of its life it's moving to white color. You can change flag position or add new flag, these different colors if you want. You can control the range in range parameter, and if you click on gear you can choose different presets of color ramp. Next type is blend. It's blending between two values, between two colors. You can use a blend ramp to control which color will apply. And as you see it again in Vex expression, the ramp based on normalized age, but you can feed any parameter you would like to. Same, you can set a minimum and maximum value for range. It's needed, for example, when your attribute, what you use to control it, have specific numbers. Next step is alpha. Basically, it's opacity of particles. If alpha equal to 1, it means that particle is fully opaque, and if alpha is 0, the particle is transparent. As well, you can control it with ramp. Again, in the X expression, we can see its normalized edge. So we can move around the flag position, and we will see that some particles become transparent. We can reverse the ramp, so particle becomes transparent towards the end of its life. Alright, now time to speak about pop group. First, let's disable alpha update and let's go back to color tab and set color to 0, so it means it's black. And press tab and create pop group node. In group name parameter, set name red. It will be the name of particle group. And duplicate pop color. In the second pop color node, set color to red. So now we can copy name of the group or choose it in group parameter of pop color, second node. So now every particle in group red will have red color. Let's go to pop group node and enable group. By default, it put all particles inside this group. And now we can play with different settings. So let's disable group by rule and go to second tab, where we can group particles by bounding object. Click on enable and choose bounding sphere. Here we can change the size of the sphere. If I hit play, we can see that all particles inside of sphere become red because they added to red group. But as you see, when particles leaving bounding sphere, it's again become black because first pop color node always working. It means we should apply black color only when particle just born. To do that, we should go to pop source node and in just born group parameter set group name, let's be new PT, and now we should choose that group in pop color first node. Let's choose it. So basically the black color will assign only on first frame, and after that it will continue to have red color even if it leave bounding sphere later. We can play around, we can move around the sphere, and as you see, the particle preserve the red color if it was once inside of sphere. We can even animate the bounding sphere. Okay, I will delete animation. And now we can go to next tab called random. So basically, by default, behaviors add to group. So it's randomly adding particles to this group. There's a chance, basically percentage, and seed to change random distribution. The second type of behavior is remove from group. To see how it works, I will use combination of two conditions. For now, I disable random, go to bounding tab, enable it, and let's go to pop source node and use impulse activation instead. I'll increase impulse count to 10,000. Go back to pop group, slightly increase size of bounding sphere, go back to random and enable it. So as you see now, the random remove from group type behavior will help us to subtract some particles from that group. Chance and seed parameters work in the same way. Alright, now time to go to combine tab. Here we can do different combinations on groups. Let's set up another pop group. Let's call it red_box. Go to bounding tab, enable bounding box and move it to left side. And sphere will keep it right side. Go to first pop group node. And now we can choose group red equals to red. And choose union with group red box. So basically, when we apply this, you will see that now the particles what inside of red box group united with group red. Now we can speak about instancing. Let's delete all nodes what we have, except of basic one. I switch back to constant activation and create pop instance node. As you see here, we have instance pass parameter. So basically we need to provide pass to instance geometry. I'll create a sphere, choose primitive type to polygon and frequency to 1. And now I copy this node and paste it into instance pass parameter. Set reference to sphere. And as you see now, we have this wireframe display inside of viewport. And if you middle click on pop solver, you'll see that this node create instance pass string attribute. To show what it have, I'll split viewport and change to geometry spreadsheet. Let's hide all attributes except of instance pass. And as you see, this attribute contains the full path to instance geometry, in our case it's sphere. So that's how it's finding the proper instance mesh. But if we go back to SOP level, as you see, we don't have even wireframe display. Let's import in clean way particles into SOP. I'll create DOP import field, drag and drop PopNet into DOP network, choose pop object, and in presets choose particles. So now if we change display to DOP import field, we'll see only particles. And now let's create instance node. So as you see, by default, instance attribute set to instance pass. And when we display the instance, we see our instance geometry correctly. Now we have same size for all particles. Let's adjust it. I create attribute randomize. And in attribute name, I set p-scale. P-scale is responsible for particle size. So as you see now, we have different size for each particle. I'll decrease amount of particles to 5. And as you see, the problem now that size of particles is changing when sum of particles dying, because particle number is jumping for them. That's why we need to use ID attribute to assign p-scale attribute. So let's go to options and click on seed attribute. By default, it's already set to ID. Now size will be consistent. Second option to instance geometry is copy to points node. Let's go inside of PopNet and increase constant burst rate to 500. I will mute instance node and create copy to points. Plug to first input sphere and to second one particles. And as you see now, the sphere is copying onto particles. By the way, I forgot to mention that pop instance by default give you pack geometry. So basically, if you want to operate on it later, you should create unpack node, and then you will see full primitive count of geometry. All right, let's go back to copy to points. Here as well, you have an option to create pack geometry if you need to save memory. You can click on pack an instance and you will see now we have only 498 pack geometry. So basically same amount, how much particles we have. But what if we want to use a library of several geometries to copy onto particles? In that case, let's create a couple more geometries. I'll create a box. and create LOP cylinder, or if you don't have LOPs installed, you can use a tube. Because cylinder centroid node in coordinate center, I'll create transform node and click on move centroid to origin. Now time to create merge and merge all three geometries. And reconnect, copy the points. Now as you see, all three meshes copy on every particle. So basically we need to use some attribute to understand which geometry goes to which particle. For that I'll create attribute from pieces node. First input is particles and second input should be geometries. But as you see, the name attribute is 0 right now. It's because we need to create first the name attribute for every geometry what we have. I'll do it with assemble node. It automatically creates a name attribute. If you will check the primitives in spreadsheet, you'll see name attribute and every closed geometry have a different name. Select attribute from pieces and switch to points in geometry spreadsheet. As you see now, we have proper name on points and we can choose mode how the name will apply. So it can be random, it can be cycle, and so on. We can even middle click and display name attribute in viewport. So you see each point have different value. Let's connect attribute from pieces to second input of copy to points. And first input connect to assemble. As you see, it's still not assigned just because we need to click on piece attribute name. And now every point have different geometry. Let's move on and speak about pop force. I'll delete all nodes except the basic one. Increase constant burst rate to 15,000 and life expectancy to 3, so particles will live longer. Press tab and create pop force. This node allows us to add force, directional, and turbulence. So let's set force in x equal to 10. So as you see, now we have diagonal motion, and if we increase amplitude of noise to 10, we start to see some turbulence value. Let's decrease force to 3 and change swirl size for noise. Swirl scale help us to scale force in each axis separately. Pulse length, the duration of lowest frequency animation. Roughness is scale for each new iteration of noise. High values will give you bigger jitter in motion, and lower values will give you smooth behavior. Attenuation, responsible for noise attenuation exponent. And turbulence, its level of detail. Usually you will use values between 1 and 5. Let's create pop wind node. It looks very similar to pop force. The one difference, it has a resistance attribute and wind speed. So this node is a bit tricky because when you create it, as you see, amplitude for noise is 0 and wind velocity 0 as well. But this node still will affect your simulation because a resistance parameter set at 1 and it basically operates as a drag force. You can see difference in velocities if you start playing with a resistance. When you increase this parameter, you will see that particles move slower, and if you decrease it, they move faster. So just keep it in mind. But if you have any value in noise or wind velocity, the air resistance will be responsible for determine influence of these node forces to particle simulation. Let's set noise amplitude to 5, spheral size to 9.3, and wind velocity to 10 in x. And you see if you play with wind speed, it basically works as a multiplier for directional wind. If you increase it, you'll see that there is much more directionality in the motion. As well, here, like in other pop nodes, we can use Vex expression to control every parameter. We will speak on it later. But for now, I will delete this pop wind and pop force and create new pop wind, and let's check how we can work with multiple pop wind nodes. I'll set wind velocity in Z20 and amplitude of noise to 3 or even maybe 5, increase spheral size and increase air resistance to 10. I'll disable gravity for now, so we can have only wind affect the particle motion. I will duplicate the wind with exact same settings. Only one thing that I will change is direction will be opposite for the first wind. I'll put minus for Z value. And as you see now, both of them compensating each other because air resistance parameter is the same. So let's set first pop wind to 20, and you will see that now it start prevail until we set the same value for second pop wind. And now if we create a pop drag, you will see that this node has wind velocity set to 0 and air resistant to 1, which means it works like drag node. And if now we plug it after both winds and increase air resistance, you'll see that it's basically the drag the simulation down until we set any value in wind velocity. If we set to 5, it starts affecting like a separate force, and air resistance basically control the influence of this force. And if I set wind velocity in y again back to 0, you'll see it become again a drag force. Okay, let's delete them, enable by gravity and go up to sub level, move grid higher. I will set a ghosting flag to it and create sphere. Scale it a bit and move it to left. Alt-click to set key for center parameter, go to frame 55 and move sphere to right, and click again to set new keyframe, then hold shift and shift animation to start later. So we have our sphere moving through the cloud of particles. Go back to pop network and create pop wind shadow. And this node should go immediately after pop wind node. But before that, I'll connect sphere to third input, and after sphere, I'll create point velocity to calculate velocity for the moving sphere. I'll choose display trails in viewport so you can see we have velocity, and change velocity approximation to central difference. Okay, now as you see, nothing happened, simply because we don't have pop wind node. Let's press tab and create pop wind. Before pop wind shadow, let's set wind directional velocity to 10 in z-axis. Even maybe 2. Okay, 2 is good. Oh, actually maybe even 1. And as you see, now we have portion of particles moving in direction of motion of the sphere. Let's add some turbulence. Increase swirl size. And if we now click play, you'll see some particles inherit sphere velocities. I'll create transform node and move sphere slightly up. Okay, cool. Here we have couple parameters like ray direction can be relative in the opposite direction of wind velocity or can go in opposite direction of the wind and can be aligned with particle velocity. Affect existing mask parameter gives you options what to do if you already have a mask in particle simulation. As well, you can control maximum distance from object. Now let's keep only emitter grid surface and check another method how we can activate particles. I will move down grid to 0 and remove both wind nodes. Let's keep gravity and I press tab and create pop Awaken. This node will help us to activate or deactivate particles. First, let's create attribute create node. And set stopped attribute, set value to 1, so basically all particles is deactivated. And now I click on option Awaken by Volume. We can choose how we want to set up a path to the object. I'll create a sphere and we'll animate scale of it. So I'll click in first frame and I'll click in frame 54. So the sphere will scale over time. We'll create VDB from polygons and check fill interior, go back to PopNet and paste the path to the sphere volume. Alright, as you see now, as sphere grows, our particles become awaken, and you can choose actually from drop-down menu what option you want to use. We can put it to sleep, so it's opposite action, but in that case we should disable stopped attribute in attribute create. Okay, let's go back to Awaken. And as you see now, we have these artifact points which start on first frame falling, even sphere is not grown to these positions. So to fix that, let's create a pop group. Let's call it Activate. And choose in bounding tab option bounding type bounding volume and set a path to VDB from polygons node. And now we should choose for pop awaken node activate group. And now as you see, it's working correctly. It's activating only in the area where we have the activation volume. Now let's check pop axis force node. I will disable for now pop group and pop awaken and disable attribute create. Press tab and type pop axis. Alright, this node applying forces around axis. As you see now, particles start to spin around center of the sphere. As well, you can change type to torus. Let's go back to sphere, and I'll increase the height of the force. And increase lift speed. Just need to reset simulation to see changes applied. Okay, let's decrease it to 5. And as you see now, particles start moving much faster along the axis. We can as well increase orbit speed, basically its spin speed, and suction speed, the force which goes towards the center line of the force. I'll increase radius and increase suction speed so particles stay closer to the center. As you see, we have really fast motion in the beginning for particles. Okay, let's adjust the settings. As well, we can increase influence of force with air resistance parameter. And let's decrease the life expectancy to 1 and decrease a bit orbit speed. And set lift speed to 3.3, adjust suction speed. Let's increase fall off. I'll set soft edge to 1 and I will create pop force to get interesting looking motion. Let's increase amplitude. Let's say to 3. And increase swirl size. As well, I will activate nodes what give us ability to activate over time particles. Let's increase life expectancy around 2. And now we have additional turbulent motion beside axis force. Time to speak about pop curve force. I'll disable pop force and delete the rest nodes what we created. Delete the sphere and attribute create. To create a curve in Houdini, we should press Tab and type curve. I will switch primitive type to Bezier curve to have nice smooth shape. And if you select the node and press enter in viewport, you can start draw a curve. Let's draw something like that and right click and finish adding points. I will shift source object to the beginning of the curve. I will enable ghosting display so I can position grid properly. Alright, let's go back to pop network. I will set expression and constant activation $f less than 15, so mission will happen before frame 15. And create a pop curve node. Choose use third context geometry. And now, as you see, the spline for start affect particles. I'll increase life expectancy of particles to 21. Alright, now you see that the particles traveling along the curve and spinning around it. Maximum influence radius control the distance from the center of the curve where force will be applied. Air resistance, basically its influence of force. Follow scale, parameter responsible for speed, how fast particle traveling along the curve. So see if I increase it, they start traveling faster. Always keep in mind that most of curve force parameters has a ramp. So basically, if you would like to have constant force along all curve and for all affecting radius of the force, you should set properly ramp parameters. Let's set here, for example, to 1. And now force should have same strength over all length. But as you see, the particles with time just go away from curve. It's because we should increase suction scale. So basically, this parameter help us to keep particles closer to center line. And again, it has separate ramp control. Let's decrease suction scale to 2. And air resistance to 3. Even we can set lower suction scale to 1, for example. And increase orbit scale so particles can have more turns to spin. All right, something around 11. And as you see, we have this red to black transition in ghosting radius of the curve force. It's because we have this force along length multiplier. So basically how overall force applying over the spline length, like global multiplier, let's say. So again, if you would like to have a constant force, you should just set all flex value to 1. Let's be sure that all grid inside of curve. I'll pin this viewport and adjust the grid position. I will rotate it slightly in X axis and move it down in Z. All right, something like that. So it's always inside. Okay. Yeah, and you see with time the particles just travel outside of force because global multiplier have smaller values there. Let's increase pop force amplitude to 10. And maximum influence radius will increase also to 5. I'll increase constant burst rate to have more particles. So basically you just need to find the proper settings for your needs when you play with that. And now we can go and discuss pop attraction node. First I'll disable pop force and pop cure force. press Tab and create Pop Attract. This node will help us to attract particles to position or surface points or another particles. First type is position. If you choose Pop Attract node and press Enter in the viewport, you'll have axis where you can drag the position in the space. And now if you click play, particles start going in the direction of settled position. I'll remove constant activation expression and set there 1, so we have constant flow of particles. In the tab force, you can control different methods, how you would like to attract your particles. Default one is accelerate. It applies force in the direction of goal position. Force scale is the magnitude of this force. If I increase it, the particles start moving faster. Reversal distance parameter describes the distance within particles will have a repulsive force instead of attractive. Peak force distance parameter show maximum distance within. Attraction force is scaling based on distance to target, and outside of this distance, attraction force will be equal to force scale. And maximum distance is influence radius of the force. Outside of this radius, force will be not applied. If I set it to 10, you will see that no force, particle got no force now. Let's increase it back. Let's say to 50. Still nothing. It's too far. Set back to 80. And now particles start attracting again. Let's increase peak force distance so you see how particle accelerating closer to position attraction. Alright, next type is force method follow. In that case, I'm going back to goal tab and choose particles for attraction type. In that case, particles will be attracted to another particles. So I'll create a second stream. Let's go to SOP level and create sphere. Move it aside and copy pop source node. Set constant activation to 1 and impulse activation on first frame. Let's say it would be 5 particles. The stream name would be stream source first input 1, so we have different group for these particles. And I think I forgot to choose proper input for source geometry. Let's go to source type and choose use second context geometry. Okay, disable guide for surfaces. And now I'll copy pop force from the left stream to the right stream. So lead particles will have some velocity. Let's decrease amplitude to 5. Now I go to pop attract node, and now I should select particles. I'll just go and copy the name of the group and put a stream underscore and paste the group name. Alright, now you see that particles start attracting, but because we have match method average position, it goes in the center of second particle stream point cloud. Let's increase force scale to 50. And now I will choose point per particle method. As you see, nothing happened, but if we uncheck goal ID, it starts working. So first particle stream start to find point and try to follow it. I'll add some directionality to force and decrease amplitude. So the lead particles go into direction of first stream particles. Let's add something -1 in Y and -3 in Z. And now we can choose predict intercept. So followed particles will try to predict where it meets the leading particle position in time and space. So behavior would be different if we just have follow without prediction. Next attraction type is points. To show how it's working, let's go to SOAP level. I'll delete sphere and create test geometry big head. And check at shader, increase scale of it, move it to the side, and add some animation to it. Just some random rotation and position to have more interesting motion. Something like that. And I'll go back to PopNet. I'll remove second stream because we don't need any more second stream particles. I'll remove point group and choose use second convex geometry. And now if I will hit play, happen nothing. I'll choose force method accelerate, and now it starts to work. So particles try to follow big head. Let's create pop drag. I'll wire it after pop attract to have some dampening. Now it should look cleaner. Let's set eye resistance to 0.1. Yeah, so everything is working like it should. Let's set expression and constant activation $F less than 15. So particles emitting only before frame 15. I'll remesh big head geometry to show you that particles attracting basically to 2 points of big head. And as you see, they can stay, some of them, very close, and to keep them apart, you can use pop interact node, basically adding repulsive force. Let's leave it as default setting is. You can increase position force to keep particles apart even further, so they will try to avoid have same position. Time to speak about collisions. I'll remove all nodes here, go up, remove big head. We don't need curve anymore. I'll keep grid. I'll revert to default settings for center parameter and rotate. Move it up. Create test geometry rubber toy. Increase scale, disable shader, we don't need it. Move it closer to grid. Can even increase scale more. And now I will set expression into rotation X. I'll use sine function. And in brackets, I will write $F. I need to multiply it, for example, by 40. Okay. Maybe by 20 and multiply everything by 5, by 15. Okay, so we have some kind of tilt motion. We will use the rubber toy as a collision geometry. If I shift click on rotate parameter, you can see that this expression just gives us a sine curve, infinite sine curve. As well, you can use motion effects if you would like. There is plenty of option. You can use noise or another thing, but I will use a simple sine curve. Okay, let's go inside of pop network. I will enable back gravity and I will set constant activation to 1. And life expectancy around 2. And I will create pop collision detect node. This node helps us to detect collisions and apply certain operation on collision. First, we need to connect our collider. I will choose second context geometry. And as you see now, every particles what collided with collision geometry become red. So we can clearly see particles on hit. As you see, we can uncheck this option, color hits. In this case, it will don't have any color. Now we can change the response. For example, I'll choose die. It means every particle, when it's colliding, will be killed. Let's go up and create a merge node. And I will pin the viewport so we can always see upper level. All right, let's decrease constant burst rate to 6,000. And I'll increase maximum substeps to 5. To make it work, I need to do attribute create node and set p-scale attribute. Or even better, I can show you another node called pop properties, which allow us to set universe scale as well. We can adjust it here and set, for example, 0.1. Yeah, so as you see, this time we have no stepping. All right, so now our particles killing on collision. I unpin viewport, and now we can set response to stop. So as you see, any particles what's colliding just immediately losing any velocity and stop at the same position. Another response is stick. So it's not just stopping, it's sticking to the collider surface position and keep staying there. Last option is slide. So particles will slide on surface and drop later. It's really nice if you want to do a rain simulation or something like that. Let's create, for example, another geometry. It will be a box. I will change dimension. I'll duplicate pop collision detect and use third context geometry. And for that, I'll choose stop and click move to hit. It stays on the position in moment when the particles hit collider. So as you see now, we have one particles which is sliding on rubber toy, and another particles just stop on collision when they collide in this box. Let's increase life expectancy to 5, so particle will stay longer. I'll create sphere and plug it as a force geometry. I'll duplicate pop source and choose use force context geometry. I'll move sphere to side so you can see. And because now all pop collision detect node plug into first stream, it's not affecting right stream particles. I'll decrease constant burst rate to run simulation faster. And if you want colliders affect both streams, all you need to do is just to move this node and connect it parallel. So in that case, it will influence all particle streams, just to remember. All right, but what if you want to have a bouncy behavior? So basically, basic collisions like we expected to have, not sliding, not sticking, but just bouncing. In that case, let's remove these nodes. And we need to use a static geometry. Let's create merge node. I'll connect it after gravity and create static object. I will plug it into merge. It's very important to remember that there is a relationship, so left input affect right input. So basically everything on left side will affect anything on right side. You should switch to be able to use static object correctly, or change affector relationships to mutual. In that case, the order doesn't matter. So here we can fit our collision geometry. Let's copy test rubber toy. Go inside. And in subpass, I will set pass to collider geometry. As you see, our geometry have animation, but in the simulation it's not animated because we need to click on use deforming geometry checkbox, and now we have animation. Particle starts colliding, but the bounce is really big. We will fix it a bit later. Here you can choose collision detection. It can be a surface collision or volume collision. I'll show you how to do volume collision in a minute. For now, let's keep surface collision and go back to bounce settings. I'll decrease bounce parameter to 0.1. It shows how fast particle on collision loses energy. So if you have bounce at 1, it means it will not lose energy over time at all. And 0.1 basically just keeps 10%. Bounce forward shows if tangential motion of particle will be impacted by friction or not. If it equals 1, It means it will be affected only by friction. Friction parameter shows the scale of friction for particle. Dynamic friction scale shows the scale of friction for sliding object between 0 and 1. Let's create a ground plane and connect it to merge node. So now we have and ground collision and collision for rubber toy. Ground plane have similar settings for physical parameters. As well, particles have their own, so all of them should be considered. Bounce is too big, so let's set bounce for ground plane 0.1 as well. In pop property, you can control as well some physical parameters like bounce, bounce forward, and so on. And if you need to apply it to certain stream of particles, you always can choose what group you want to use, or even if you have just some portion of particles selected into group, you can control separately for each group. Because in pop object, settings apply to all particles inside of same named pop object. Let's decrease, for example, bounce to 0. And as you see now, particles have no jump at all. And if we set it to 10, they will fly into the air much higher. Just basically exploding all around. That's too much. Okay, now let's check how we can use volume collisions. By default, it uses maximum axis method. And if you would like to see the collision guide, you always can check it and uncheck display geometry so you can see how volume geometry looks like. Okay, so if you would like to use a custom volume, you should choose volume sample mode and create SDF volume for your collider. You can use collision source node. It does everything. It's as well calculating the velocity for your object. If you click on display point trails, so you see that that geometry doesn't have this attribute, but after collision source, it's already calculated. You can choose approximation settings as well. And in volume tab, you'll have your volume settings. Let's use second output, create a null, call it proxy. And if we display the null, you'll see that we have SDF surface. This name collision. Let's set voxel size 0.05 and go back to PopNet. And now in proxy volume, we should put path to proxy volume, what we just created, and change sort path to collision source node. Can display geometry, uncheck collision guide. And now we're using volume collisions instead of surface collision. Let's set bounce to 0.1. Now I can speak about pop replicate node. This node generates particles from particles. Let's press tab and create pop replicate. I'll connect it after pop property. And as you see now, every particle have a certain amount of particles around it. And what we should know that when we have a collisions inside our simulation, we should have a couple of attributes what go alongside with that. And one of it is hit num. Basically, it gives 1 on collision and 0 when particle is not colliding. So it can help us to determine where a collision happened. So let's choose option emit from attribute, and in attribute parameter type hit num. So particles will be replicated only during collision. I'll decrease constant burst rate to 100 and change life variance. So if you zoom closer, you see that the particles start replicating when it's colliding with colliders. I'll decrease uniform scale, and now we will see it not so good because the P scale is affecting the radius of replication. Let's use impulse activation and impulse count to 3. And add to inherit velocity. I'll set 1 and 0.5 in Y. So now we can see it better. We have slight extra velocities on top of inherited one. Okay, I will swap. I'll put 0.5 into velocity in Y and 1 into variance in Y-axis. So now we have kind of rain setup. As well, you can add a noise to the replicated shape, so it will be not a perfect sphere. As well, you can choose different shape when you're replicating particles. It can be sphere or line, cylinder, and so on. As well, in pop network, like in SOPs, we can control attributes of particles with VOP. In this case, it would be pop VOP and pop Wrangle. Both of them using VEX. Just pop VOP will have a visual interface for that. Let's check pop VOP node. I'll connect it with pop property. And let's say we want to have more interesting motion when particles falling. In this case, I'll go inside of pop VOP and add curl noise to particle velocity. So I will adjust it slightly to have more interesting motion. First, what I'm gonna do, I will break velocity into vector and scalar value. To get direction, I'll use normalize node, and to get speed itself, scalar speed, I will use length. After that, I'll create a curl noise and plug position into position input. Create add node and add noise to direction of velocity. Normalize vector again and multiply it by scalar speed. And connect it to output velocity. As you see now, we have some noise in motion, but noise have a very big impact. So to decrease its impact, I will use mix node. And I will mix between untouched vector of velocity direction and velocity with noise. And now bias will control how much we affect in the initial velocity direction. Let's set it to 0.25. So just slightly adding it to basic velocity direction. Pop replicated will be stream underscore pop replicate 1. So we can apply pop VOP only for the main source particles. So when particles replicating, they will be not affected by this pop VOP. And then just fall affected only by gravity without any velocity direction modifications. I'll increase life expectancy to 5. And for pop replicate, to 2. Yeah, so as you see, when particles replicating, they're not affected by pop-wop node. As well, you always can click right mouse button on pop-wop node and expect Vex code, what's node doing for you. So basically here you can see that this is just a visual interface for Vex. Okay, let's disable it and let's create something more fancy. Let's say when the particles touching the ground, they start spinning with vortex force. To do that, let's go back to SOP level and create velocity volume. Let's create VDB node, call it density. Add one more volume, call it V for velocity. Choose vector field and vector float velocity for vector type. After that, I'll create VDB activate node, plug VDB, and use as reference box volume. So if you see, now we have two VDBs. It's for density and for velocity. And now we should modify velocity. I will use volume velocity node. And here we can add vortex force. I'll increase angular velocity to 3. And to visualize it, I will scatter points into volume and use volume trail node. Connect points and volume, choose V for velocity volume. And as you see now, we have this vortex velocity field. We can control different parameters if you need in volume velocity node. I will shift slightly the center of it. Create null to export and call it volume. I'll copy, pass to null, and create new pop-wop. Here we can use separate inputs data. I'll use SOP for input 2 and put a pass to velocity volume. Let's create volume sample to read density and volume sample vector to read velocity because it's a vector attribute. Connect output 2 to file name and position into sample position. And for signature, I'll use not primitive number, but primitive name. I'll type density for sample file, and for sample vector, I'll choose primitive name and V. Next, let's create compare node so we can check if particles inside VDB volume. By default, values inside VDB volume is negative. So if we set less than 0.1, it should work correctly. And now time to create two-way switch. In first input, we'll plug velocity, and second one, velocity from volume. So basically, if particles inside of this threshold, we will have velocity from volume. And now if we hit play, you see that particles, when they start getting closer to box, they start spinning affected by volume velocity. And let's shift a bit, center, increase force. So you can see how it works now. Right, let's disable it. And now I'll create pop Wrangle. Basically, with help of this node, you can use a DirectVex expression to control attributes on particles. Doing the same as pop, but here you just should type code yourself. We will use again HitNum attribute to get when particles is colliding. I'll use simple expression if HitNum equal to 1, then we will add to velocity some custom vector. In my case, it would be 1 in x, 1 in y, and 0. Okay, let's do 10, 10, 0. And now when particles colliding, they will go to side. Let's set just 5 in y and 5 in z to see it better. Yeah, so now you see when particles colliding, they just have additional velocity, what pushes them to the left side. As well, we can use, for example, to change the pop Wrangle to change another attribute. Let's say color, and we can set color to red if it's colliding. But before that, I will set default color to 0 because we don't have color set yet. And in this case, when particle colliding, it will have red color, and when it's free of collision, it will be black. One of the basic nodes what I forgot to mention is pop kill. So let's disable pop Wrangle and enable pop replicate, move it up, and create pop kill node. Connect it after pop replicate. So as you see, first we can enable deleting particles by rule. By default, that equal to 1. That means all point replicate particles will be deleted. So let's type if attribute age bigger than 2.2, then particles will be deleted. So it have a very short lifespan. Basically, here you can use any Vex expression to control rule for deletion. If I grab it and apply before pop replicate, it will affect main particle stream as well. Okay, let's disable rule and go to bounding tab. Here we can kill particles by bounding box. First, we need to click to enable checkbox. And now all particles inside of bounding box will be killed. If you wanted to kill outside, you should just click on invert. Let's connect it parallel way, so it affecting all particles. So as you see, everything inside getting deleted. As well, you can choose bounding sphere or bounding object or bounding volume. There is also random tab where you can randomly kill particles. Okay, let's move forward. And now time to talk about spin. I'll delete all these nodes. And let's create pop spin node. This node create for us Orient attribute, even if we don't have it by default. So if we click now on information, you'll see that there is no attribute. And when we connect pop spin, and I'll play a bit simulation, now we have it, Orient. Because Orient, it's a vector 4 quaternion, is responsible for particle orientation, and in this case, spinning. Let's disable it and go to SOP level. I'll create DOP import fields node. I'll put DOP network popnet, choose default object, and choose preset particles. And now I will create copy to points to instance geometry onto particles. I'll create box connected to first input and to second input particle system. I'll change size in z-axis to 4. And let's remove any collisions. And I disable gravity as well. As you see, here's no velocity attribute. So let's set initial velocities. I'll set it to 7 in y and 7 in z. And rotate viewport. So now they go to the side, this case to the right side. And as you see now, particles starting to align this velocity attribute. It's because we don't have normals or orient. Orient is a high prio, so if you have orient attribute, it always will take into consideration first. And only after normals and after that velocity. So let's create attribute create node, and I'll set up normal attribute. Let's display point normal in the viewport. It should be vector attribute, so I'll choose size 3. And as you see, now particles stop aligning with velocity and aligning by normal attribute, because it's higher prio than velocity in this case. But if after that I'll create new attribute randomize node, and here this node as well can create attribute even if it's not existing. So I'll type orient, and I'll choose dimension 4 because it's quaternion, so it's vector 4. And I choose direction, orientation, distribution, and cone angle 180 degrees. So if we check, we have now orient, and you can see it's nicely displayed in the viewport. So we have random rotation. And now particle system will consider orient as a primary orientation attribute. Just what I said about hierarchy. Orient is the most proper way to control orientation and spinning, so I suggest you always to rely on this quaternion vector 4 orient attribute. Now disable all nodes except of point velocity, so we have just initial velocity. Go inside of pop network and enable pop spin. And if you click play, you can see that spinning start around y-axis. Let's set axis to z and spin speed to 360. It measures by degrees in second. Let's set some curl noise to initial speed, increase scale and decrease swirl size. Disable display of orient attribute. And now you can see that instance geometry start using orient attribute to spin. To align particles with velocity in orient attribute, we can create attribute wrangle and type attribute orient equal dihedral function, which allows us to align one vector onto another. And first vector would be 0, 0, 1, and second one normalized velocity to get the direction of it. And now if we will display orient, it should be aligned correctly with velocity direction. Point trail usually shows you opposite direction of particle movement because it's a trail. Okay, let's create attribute create and in name type pscale to adjust the size of instance geometry. Let's say it would be 0.3. Okay, let's disable attribute Wrangle and enable back random orient attribute. And we can go inside of pop network and choose axis relative to particles orientation to have local spinning. You always can change the spin axis. I'll set X. Let's add a pop wind to have some turbulence into motion. I'll set amplitude to 3 and a resistant very small, let's say 0.09. I will pin SOP level viewport to 3D instance. And now in the Vex expression, we can control speed based on velocity. So I will use length of velocity vector to get scalar speed. And then I will set spin speed parameter equal feed speed if speed between 0 and 10. It will have spin 10 degrees and 360. So basically, faster particle moving, faster it's spinning. That's how you can use Vex expression to control any parameter in pop nodes. Let's go up and disable attribute randomize and instead enable attribute wrangle, which gives us ability to set orientation based on velocity direction. And as you see now, it's rotating correctly, it's going and rotating in direction of motion. And when speed becomes slow, the spin slow down as well. Can disable wind. As well, very handful node called pop speed limit. So basically you can limit minimum maximum speed and minimum maximum spin. So if you set it to any value, the speed of the particle will be not higher than this value. Or you can set a minimum speed. If it's not equal to 0, it means particle always have slight motion. For example, let's say 3, it means at least particle speed would be equal to 3. Same you can do with maximum spin to limit spin speed. Let's remove pop wind and pop speed limit and enable back gravity. As well, I'll disable point velocity and attribute wrangle to align orient with velocity. So now particle just falling down. And how we can control this external attribute, direction of spinning. To do that, we can again use a pop-wop node. Before that, I'll reduce life expectancy to 2 and press stop and create pop-wop. Go inside and create node called random. Basically, it gives you random value between 0 and 1. And I will plug ID as an input. So for every particle will be different value between 0 and 1. Signature, I will set 3D output. So we have a vector. And I create destination minimum -1, -1, -1, and +1 as a second destination maximum parameter. Let's call it random spin axis. So it would be just random axis to rotate around. And now here we can just hold cursor on axis to see the proper name for this parameter to call it in Vex expression. It's called just axis. Axis equal random spin axis. And as you see now, this attribute have a random value per point, per particle, and it's using to spin particle around this axis. Let's add pop drag. Just decrease air resistance. And increase life expectancy. Let's slow down the spin. And decrease scale of particle. Even smaller, let's say 0.1. Unpin the viewport, go back to PopNet. And now I'll show you how you can align particles on collision. Let's scale up collision geometry and move it down. And I will rotate it in y-axis as well. So now I will need to create pop collision detect to import collision geometry. Use second context geometry. Okay, so collision is happening now. Let's go up and create a merge and display together instance geometry on particles and collision geometry. Now you can go to Behavior tab and in response choose Stick. So now particles will stick to an object. But as you see, they keep spinning because the spin is constant. So to do that, basically we just need to pick up the attribute from collision geometry to stabilize Orient attribute for particles. You can do it several ways. I think the most efficient would be just to use specified function, for example. But to do it the simple way, I will do it just with simple attribute transfer. Let's increase life expectancy of particles to 6. And now what we need to do is create proper Orient attribute for geometry, what we will read after, and transfer it to particles. To do that, I will use node called Orient along curve. I'll connect geometry. And as you see, by default, it creates normal and up attribute. I don't need it. So uncheck them, and I will check quaternion Orient. Now we have Orient attribute, we can display it in viewport, and I will go up and in tangent type I will choose previous edge to have nicer distribution. Let's disable display of Orient attribute. And since it will be post-process, so we don't need to connect this node directly into simulation, I'll create attribute transfer and choose Orient attribute for points and set distance threshold. So the distance where we can already start copying attribute, let's set up to 0 and blend width set up to 0.15. Okay, let's set distance threshold to 0.1. And now as you see, the particles start inherit attribute from surface, and they just stick in and get rid of any spin on the geometry. Another note what operating with Orient attribute is pop look at. Let's delete these nodes, just clean up the space a bit. Okay, I accidentally remove box. I still need it. Alright, let's keep only that thing. I'll move to 0 emitter surface and go inside of PopNet, delete unnecessary nodes, and disable gravity. Okay, let's disable constant activation and set impulse activation to 100. Okay, 500. And set activation frame equal to 1, so it would be created only in first frame. And create pop look at node. Connect it. And as you see, we need a reference object. So let's go to object level, not sub level, but object level, and create a null. Let's move it up and to the side in x-axis. And I'll click to set a keyframe. Go to frame 64 and change position. And set another keyframe. So it go in diagonal way. Let's go inside and choose a null object. I'll disable use up vector and increase p scale attribute to have bigger size for the instance particles. And now as you see, particle start following the null animation. So basically it's always looking at target. That's how you can use this node. Another option to create particle system is to use pop location node. Let's remove pop source, press tab and create pop location. Here you can choose a position where emission should happen. I will move it up. Use impulse activation. I will emit only on first frame. Let's say 500 particles. With life expectancy 1.5 and variation 1. I will add velocity in y-axis and z-axis. So we have kind of burst of particles. Increase variance in z-axis as well. And variance in x-axis and z-axis. I'll quickly create pop VOP and add same technique what we used before. I will normalize velocity to get direction and use length to get speed of particle. Then create curl noise, plug position, and add curl noise to direction. Normalize vector after, and mix it with original direction, and the result multiply by speed, and plug it to velocity output. Let's add some small bias, so we add it slightly. I will decrease frequency to get bigger spheral size. Increase amplitude to 3. Okay, something like that. And as you see, the stream will be named pop location. Now we can go up, and I will show you another cool node in Houdini, which called particle trail. It creates slides based on particle velocity. Let's go to shape. We can choose frame duration, so for how much frames it look to create trail. As well, you can use method for shutter speed, same logic as when you're rendering particles with motion blur. If we need more substeps, we can increase it this substeps parameter. We can control widths. To see it, we should create polywire to create geometry around line, and use attribute width to control wire radius. And now we can check overall scale parameter. As well, we can adjust tail widths, we can adjust head widths. We can use scale along length, so it would be relative, and use ramp to set whatever shape we want. We can scale as well over normalized age, so basically it will be scaled during life of particle. It can start bigger and then slightly disappear. So we have option scale by noise, and you have basic noise parameter like element size and amplitude. As well, you can set minimum width, so basically it will clamp value if you don't want to have zero width value. In look, you can control alpha, so it's opacity of particle. It changes alpha attribute. Again, you can control scale along length and control it with ramp. And scale over normalized age, so it will be opaque in the beginning and transparent in the end. If you're using default ramp setting, you can adjust it with ramp as well. You have intensity, so you can use later in render. So you can adjust color, you can set constant color or use ramps along length and over normalized edge. It's great to use for sparks or effect like that when you don't want to use velocity motion blur in render time. Time to speak about volume advection. Let's move grid to the origin. I'll change size 7 and 7. Go inside PopNet, delete PopWop, delete ground plane, delete pop location, and create pop source. Keep scatter on surface, use first convex geometry. And in burst up, I'll set impulse activation to 1, impulse count to 1000. In impulse activation, I'll set expression emit particles on first frame. I'll disable gravity and delete particle trail node. Dive inside PopNet and create Pop Advect by Volumes node. Connect it. And as you see, we need to set pass to velocity volume. I'll create VDB, name val, vector field, and type velocity. I'll create bound for the grid and increase lower and upper padding for y-axis. Then I create VDB activate node, plug VDB to first input and to second input bound, and choose reference to fill bound with VDB volume. After that, I'll create volume velocity. And add vortex. Create null. And call it vel for velocity. Copy it and paste it into subpass. So now as you see, particles starting to be advected by volume velocity. And when it's reached limit, you just keep slightly moving. I'll create pop attract node. So they're trying to reach the center. And increase peak force to 1, even to 3, peak force to 3, and force scale to 10. Okay, something lower, let's say 4, 2, for now, let's quickly create Pyre simulation. I'll create sphere and Pyre source to fill sphere with particles with needed attributes for rasterizing later with Houdini. I'll choose mode volume scatter and initialize smoke. So we have density and temperature attributes. After that, I create Pyre Solver. Of course, it's not working because we should rasterize it. Let's create volume rasterize attributes. Inside of here, choose density and temperature, and for coverage attribute, I'll choose P-scale, and click on normalize by clamp coverage to have smoother feather for volume. All right, now let's go up to fast. So let's go to shape and decrease buoyancy to 0.5, and add some turbulence to the simulation. Set up to 1. Okay, maybe we should decrease temperature value. Let's say 0.1 instead of 1. And as you see now, we have velocity, 3 volumes. We can go to Output tab, and I need just density and velocity. And I can plug sphere as emitter geometry to particle simulation. And connect velocity null to Pyre Solver. So we will read from Pyre simulation velocities. There is different advection types. Basically, it's force, but you as well can update velocity. It would be more accurate. You can blend velocity with any other pop forces. And as you see, the problem here, like if you don't have them, the particles may just stop when they reach the limit of velocity volume. So in that case, you can add some additional small pop force. Decrease amplitude, even smaller. Just to have something when volume velocity equal to 0, and set velocity blend between 0.5. And if we increase pop force, you can see it better. They're moving on the edge. Updated position is the best advection if you want to move particles precisely with the volume velocity. Advection method allows you to use different from single step method and use CFL condition to set how many voxels should be considered due to calculations. The number higher than 1 may cause some issues, but it will be traced much faster. The lower value will increase simulation time, but would be more accurate. Now we can speak about instancing in Karma and Motion Blur. Let's plug grade back as emitter. And let me display and fix those issues with vortex force. Because yeah, they going in diagonal. So let's go up and I'll show you why it happened. That's so great. I can use points to display and second input for velocity. And let's move the center of vortex to the center of emitter. And if we check now from side, you'll see that we have this bulge. So let's click on constant velocity and set it to -1. So we have flat vortex. And now it's working good. But we have these stuck no velocity particles. Let's create a pop kill. Enable the rule. Let's create float speed, local variable, equal length, velocity. So it would be a speed of particle. If it's equal to 0, then we will remove it. Okay, that's interesting. I think, okay, let's, if it less than 0.2, set like that. Okay. So now we have only moving particles. Let's decrease amount of particles to 200. And go up to the dope import field and create loop network. Go inside, create soap import node to import particles inside of Solaris. I'll create null, flag dope import field, call it particles, copy node and paste it into subpass. Change sublayer to copy sublayer. Create new camera. Adjust it and create merge node. Click on lock sign so I accidentally do not touch and move camera later. It's needed only for positioning camera. Create a karma nodes and I will create some dome light as well and merge it. Right, as you see, we have velocities here. Let's increase the scale of the advection force to 7. And it's always good to recalculate velocity after. I'll create a point velocity node and check match by attribute to use ID and choose approximation central difference. Go back to Solaris and I'll use CPU to render. Increase exposure of dome light. And go to camera effects. And as you see, to enable velocity blur, I should go to motion blur and choose velocity blur in drop-down menu. Now I'll put display flag on the camera in the settings, and as you see, motion blur start working for particles. You can increase sub-steps if you need it. I'll render it to M-play. Let's decrease exposure of light and increase primary samples to boost quality. As well, we have an option to compute acceleration. It's usually better for this kind of rotational motion. And you should choose velocity blur to acceleration blur. Let's render it to M-play. And if you see, it's getting better curved motion blur for such motion of particles. don't have this straight, steppy shape, so keep it in mind. I'll disable for now motion blur. And let's check how we can instance geometry in Karma. Boost count to have less particles. First thing, it's always we can do copy to points on SOP level. For example, I'll create a box and sphere. And peak head, test geometry peak head without shader. I will merge objects together and create a sample node. So every geometry will have its own name attribute. Create pack primitives from them. Increase p-scale attribute. And now I should assign randomly or in cycle name attribute to points so they know which geometry should be copied. I'll use attribute from pieces node like we discussed before. I'll split viewport and choose geometry spreadsheet so we can check if we have proper name attribute on points. Yeah, we have it now. So I'll go to copy to points and choose piece attribute name. So as you see now, we have every point, every particle have its own object assigned. How we can do it inside of Karma? I need to plug null after attribute from pieces, so we have a name attribute. And let's go to instancer node in Solaris, create object merge, and paste pass to particles, null, create SOAP import, and copy pass to assemble, paste it in SOAP pass, sublayer style copy sublayer, plug it into second input. And as you see now, we have the issue that all instances doing the same thing. So basically, it's just copying all objects onto the same point. So to fix that, we should create a collection node. I'll switch layout to Solaris. I have import pass prefix here. I will call it library. And as you see, we have these prototypes, piece 0, piece 1, piece 2. So let's connect collection after SOAP import. And here I will type /library /prototypes /star. So basically I'm writing the pass to the geometries and collection name geo. Now we can go back to instancer node. And here, prototype primitives, choose collection geo. So as you see now, it just randomly, because prototype index random, in drop-down menu, select it, So just randomly assign the geometry to point. But what if you want to use exactly the same how we see it in SOP level? In that case, you should just switch from drop-down menu to name attribute. In this case, I will pin viewport for Solaris and unpin it here. So as you see, it's totally same distribution because it's referenced by name attribute now. And if you change any offset in the attribute from pieces node, it will automatically apply in Solaris as well. So you can preview like that on SOP level. Okay, and now we can set display flag to camera render settings, and let's render it with CPU. And as you see, the motion blur is not there, just because we disable it. I'm enable it. Okay, it's because we should set up instance velocity blur as well. It's here. So choose from drop-down menu, velocity blur or acceleration blur. And if you have acceleration attribute or velocity attribute, it will blur it. That's how instancing and motion blur working in Solaris. So we can go to next step. Let's do better advection setup, more accurate. I start a new scene and create geometry object. Let's go inside, create box, change size in y-axis, and create transform node. To move it up, and I'll slightly tilt it. Okay, now let's do RBD solver and simulate falling of this object to the ground. I'll choose ground type ground plane. And create RBD configure to adjust rotational stiffness. Click on rotational stiffness and increase it to 2. Okay, so now we have a box falling to the ground. And now we can create emitter for volume. I'll do box again, try to match height with current falling box height. Next, create Pyro source node to create points from volume. In this case, in the mode, I choose volume scatter, decrease particle separation, and add attribute density. Now I will rasterize volume by attributes. And I copy separation parameter to voxel size. Choose an attribute's density and p-scale for coverage attribute, as well check normalized by clamp coverage. Create Pyro solver. Connect the first input source, volume. In sourcing, I delete temperature field, burn field, velocity field. We don't need them. And for density field, I'll increase scale to 80. So it should be dense. I need sourcing only on the first frame, so I'll create delete node, choose delete by expression, and type $f equal to 1, and in operation, choose delete non-selected. So we have emission only on first frame. As you see, because of dissipation, volumes start disappearing. So let's go to shape, to fields tab, and disable dissipation. Now I'll create unpack node, because in our debug solver we have packed objects. After that, I'll create point velocity to recalculate velocity of the falling object, choose central difference. And now I'll create VDB from polygons to create collision volume. I'll set voxel size to 0.02 and name it collision. As well, I check fill interior and add attribute point velocity, choose velocity from vector type, and connect it to the second input of PyroSolver. As well, I'll go to collisions and change collision type to SDF plus volume velocity. Now I can add ground plane. I choose closed below Y. And as you see, collisions start to work. Let's copy particle separation and set paste relative reference to voxel size of simulation. As well, for collisions, I'll increase velocity scale 1.5 to increase impact of falling object. To smoke. In fields, I will add a speed field so we can use it to control turbulence. I'll go to Shape tab, choose Turbulence. Threshold field would be density and control field would be speed. I will compute range to see the values what we have. In this situation, I'll set 0.1 and 1 for the input range. Okay, so now when collision happened, turbulence starting to be activated, increase maximum octaves, and we can even increase a bit resolution of simulation by decreasing voxel size. Okay, something like that. I will move emitter a bit left and extend it slightly. Now it's better. Maybe even a bit more. Now go to Output tab, disable temperature, flame, and CD fields, convert volume to VDB, and use 16-bit float. Let's create volume VOP after, and VDB analysis node will help us to operate on velocity field to calculate lengths, so basically calculate speed of velocity. I'll choose output name custom and call it speed. I'll plug it into second input of volume VOP. Use volume sample to sample field from the second input. By name, call it speed. And multiply density by speed to have only areas where speed equal not to 0. As well, we can feed range if we want to clip even more. Let's say the minimum would be 0.2, even 0.3. So we get rid of 0 velocity volume. Now create point from volume and change point separation to have more points. I will increase jitter scale as well. Let's create grid and node called match size. so grid would be same size as source box. Check scale to fit. And now I will scatter points on it. Let's say 600,000. I will use them as emitter for points, but will activate them by points from volume. Let's do attribute create node, set value to 1 and call it activate. Now I will use attribute transfer to transfer this attribute to static points. Choose activate attribute and decrease distance threshold to 0.2 and blend width will set as well 0.2. Now we can display attribute and see how it will affect. And let's create node attribute from volume. I'll separate velocity volume. Create null, call it velocity. And let's transfer velocity to V attribute. So particles will have velocity now. We can transfer velocity as well to static points. To be clear, we can put name val to be sure it's transferring correctly. I'll create attribute VOP. And let's create bind node and import activate attribute. After that, we can create compare node. So basically, we can isolate only activated particles. I'll create if block compare to condition. Let's call test less than and compare if it's less than 0.14. We will remove point. Connect handle and ptnum to ptnum. So now if points is not activated, they will be removed. As well, we can add additional condition, delete particles based on velocity as well. Let's plug velocity to length node and compare the speed particle, so we can connect it to second input of OR node and increase threshold, so only high speed particles will be used to emit. And let's use frame to stop emission after certain frame. I will use test greater than, and let's say frame 45. Particles will be removed after frame 45. In the global seed of scatter node, I will set $f expression, so every frame it will be different seed for particles, so they not spawn in same position. And before scatter, let's apply UV texture to points. So scattered particles will have UV attribute, and then we can use attribute from map to use some texture map to inherit color for particles emitter. I will use this kind of texture, so we have more interesting color pattern for the emission. And now I can create pop network. Go inside. For now, let's decrease overall amount of scattered points to 100,000. And emission type, I'll choose all points, disable guide. Life expectancy I'll set to 4 and variation to 1, and I will remove any overlapping particles. Let's play simulation. Okay, I think I don't need to inherit velocity, and particles will be driven just by volume. I'll copy pass to velocity null. I'll paste it into SOP parameter and change advection type to update velocity for now. Let's check how it will work. Increase velocity blend to 0.95. And slightly decrease velocity scale to 0.75. Create merge node and ground plane. I'll move ground plane upper because we have left inputs affect right. Let's play simulation. Now let's import properly into SOP level, create DOP import field, drag and drop DOP network, choose pop object and particle preset. Before pop advect, I will set pop property and set a P scale to 0.001. And let's recalculate velocity. I'll choose match by attribute ID. And phrase sample I'll decrease to 0.5. And choose approximation central difference. Now create null, call it particles, to export them into Solaris. Create a LOP network. Copy particles null. To import particles in the Solaris, use SOP import, put a pass into SOP pass parameter, and choose copy SOP layer. Now I'll increase back to 600,000 emission particles. And let's wait for simulation. All right, let's go back to Solaris. And create new camera. Let's position it and unlock it. Now create material library. Click on assign to geometry and put a star because we have just particles on top. create Karma Material Builder, go on Site, and now we should use a color attribute. So I'll create geometry property value to import it, and color attribute CD convert into display color. So we should type this name. I'll connect it to color and to emission color. As well, I'll create dome light. In fact, now we use an emission color, but in case if you want to decrease emission amount, we will need some light in scene as well. I'll create Karma setup. Choose XPU as an engine. Increase best trace samples. And in camera effects, I'll choose velocity blur for motion blur. Increase exposure for light. And choose a HDR map for dome light. Now I'll do test render. Lock camera and adjusted position. I forgot to set emission intensity, and I'll set it 1 for now. Create a constant parameter and plug it to opacity. Choose vector, and let's say set opacity to 0.3 in each axis. Slightly increase best trace samples. And now I can set a frame range to render. Let's say it would be from 10 to 80. And I will render to mplay. And this is the result of the render. If you would like, you can decrease emission amount and see better influence of dome light on the particles. As well, you can use different attributes to control color or any attributes what you want. And let me show how you can do that. What if you want to use a speed of particles to control color? In that case, let's go to the PopNet. I'll go to some frame where we already see particles and create pop color node. I'll choose type ramp, and in Vex expression, I'll type feet length for velocity. So basically this is a speed between 0.2 and 1, set value minimum 0 and maximum 1. So I'll just remap it. Let's set for input maximum 2. I'll choose ramp preset to have more interesting color distribution. And as you see now, the high speed particles will have yellowish color and slower particles bluish. I can adjust the input maximum value, let's say to 1.5, and simulate again. As well, you can do it not in simulation, you can do it as a post process in attribute warp or attribute wrangle when you already cache simulation, but since it's going pretty fast here, I'll just do it inside of PopNet. Okay, and now I'll just go to LOPNet and do quick render of it to M-Play. Let's go to shader, and I will increase opacity for particles. Let's say 0.6 in every component, and I'll increase velocity to 1. Okay, and now I'll hit render to M-Play. This is the end result. So as you see, the fast moving particles have yellowish color and it go gradually to bluish when they're slowing down. That's how you can use any attribute to control the color, emission color, or any other shader attributes. I hope this course was helpful for you, and if you like it, hit like and subscribe to my channel. Cheers!